All right, we are going to get started here on Rolle's and means the value theorem. So these two theorems are very related. Rolle's is a very specific theorem, whereas mean value theorem kind of covers everything. And I'm going to explain what that means right now. So for Rolle's theorem, I'm just going to read through it and I'll explain to you what it means. So we have a function that's continuous, super important, at every point on the closed interval a to b, and it's differentiable at every point on its interior. If the two endpoints are equal, that's what that means, then there's at least one number c at which the derivative is 0. So it's trying to say that if you have some type of function, so I'll just draw some function on which this happens, so whatever. You have some type of function that has these two endpoints. It's just trying to say that the derivative at least one of these points has to equal 0. This just means this is going to be a horizontal tangent. And you can kind of see that that happens here at least one time. The way I drew it, there happens to be 3. So if you have any type of function that has that point and that point, and it has to be continuous and it has to be differentiable, which means that you're able to take a derivative at every point, then if this happens right here, you can have at least one horizontal tangent there. What is important though is, or not important, but kind of a little sneaky right here. If you notice, it has to be continuous everywhere on the interval. That's super important. Let me go ahead and highlight that. It needs to be continuous everywhere, okay? But it doesn't need to be differentiable on the endpoints. It just needs to be differentiable everywhere in between. So that means if you're coming off like a corner or a cusp on the one end line, or if you're coming off a vertical tangent, then you'll be good to go. All right. So let's go ahead and verify this on this first example over here. So it says verify the function that satisfies the 3 hypotheses of Rolle's theorem on a given interval, and then find the all numbers c that satisfy the conclusion of Rolle's theorem. So the 3 hypotheses are this continuous right here, this differentiable right here, and then this f of a equals f of b. And then we're going to find a c in which this does occur. So this is kind of like IVT 2.0. So it's really doing IVT but for derivatives. So real quick, is it continuous? So is f of x, well, it is polynomial, so it's going to be continuous. So f of x is continuous on the interval from 0 to 2. That's true because it's a polynomial, so that's always going to be true. It's also going to be differentiable everywhere. You don't need to show this. You just need to write it if it is true. This is differentiable on, it's differentiable from 0 to 2. You can, because it is true, you can put the endpoints, but I just play it safe, and I just read exactly how Rolle's theorem writes it. And then 3, we have f of 0, which by the way is 5, okay? And that's going to equal f of 2. And is that true as well? If we plug in a 2, we're going to get 8 minus 12 plus 4 plus 5. Yep, that's also true. So these all work out. I'm going to just put a little note, hey, that's 5 and that's 5, so that we're good to go. So sometimes some of these questions will say, does Rolle's theorem work? And you would actually need to go through and know this stuff. This one just says verify, so I'm really just going through everything for Rolle's theorem just to verify that it is true. And now we're going to find the number c that satisfies this. So all I need to do is this part right here. I need to take the derivative and set it equal to 0 and find my c values. And then I need to make sure my c values are in this interval. That's super important. Some people forget about that part. Find your c and make sure the c is in here, because sometimes we're given multiple c's, and one or all of them might be in this interval. So let's go ahead and do that now. So it's the second part of this question. So we have to take the derivative of f of x. Then we get 3x squared minus 6x plus 2. Set that equal to 0. Now, we could go through and factor. Unfortunately, it's not going to factor. I can just look at it right now and tell you that. This is not going to factor nicely. So we're going to have to go ahead and use the quadratic formula, or you can complete the square. People don't like doing that usually, especially when that coefficient in front is a 3. So let's go ahead and do the quadratic formula. For those of you that forgot, Hopefully you didn't forget. I have it written down right there on the side. Okay, so negative b plus or minus square root of b squared minus 4ac all over 2a. So now I'm going to get x equals 6 plus or minus negative 6 squared, which is 36, minus 4 times 3 times 2 all over 2a, which is 6. And this, by the way, is going to give me root 36 minus 24. So that's going to give me a root 12. I'm just checking my work here, make sure that I'm good. Yeah, I'm going to get a root 12. And a root 12 is really a 2 root 3. 6 plus or minus 2 root 3 all over 6. Now, if you're totally stumped and you're like, oh, I have no clue where the heck that is, I split this up and make this look a little bit nicer. So what I'm going to do here is factor out, divide everything by a 2 here. So I'm actually going to, before I do that, I'm going to split this up. I'm going to do 6 over 6 plus or minus 2 root 3 over 6. So it's going to give me 1 plus or minus root 3 over 3. All right. So now we just kind of need to know if this in the interval. The plus might only be in the interval. The minus might only be in interval, but at least one of them is. So if you don't know that, you can just use a little bit of your math knowledge here. We're starting at 1. And root 3 over 3 is less than 1, okay? Because we're dividing by a larger number, so it's less than 1. So if you add a number that's less than 1, it's actually going to be in this interval. And if we subtract a number from 1 that's less than 1, it's actually in this interval as well. So both of these are going to graduate to a C value. So if you notice, I didn't put C at all until I knew that I had a C. So since both of these answers are in the interval, I'm going to graduate this to a C. So C equals 1 plus or minus root 3 over 3. Okay, well, it's kind of hard to read there, but that is 1 plus or minus root 3 over 3. Okay, a little bit. I don't really need that much better. Okay, that's much better. It's more clear. So there's all my work there for solving for the C. If you wanted to keep this answer like this, first one right here, totally cool. If you knew that that was between 0 and 2, I didn't know that personally. This is what I do to kind of check it out. Oh, is it in the interval? So there you go. So that's Rolle's theorem. That's the first part. We're not done yet. We're going to have the mean value theorem as well, which is very similar to Rolle's theorem. Rolle's theorem is actually a play off of the mean value theorem. So you're going to have the same type of idea here, where you're going to have f of x is going to be continuous. Highlight that for you. So f of x is going to be continuous on the closed interval. So this is the same first two things here, and it's differentiable on the interior. So this one only has two things you need to show, not the third one. The third one's very specific to Rolle's theorem. Then it says that the secant, that's what that is right here, that the secant, if there is a secant somewhere, that equals the derivative. Okay, so that's all that that's saying. So if I have two random points, I'll draw this out again, and it's kind of written right here, but I have two random points, boom and boom. I just have some function, whatever, and it's differentiable continuous. This secant I'm drawing in blue, I'll do a dashed blue line, that slope happens somewhere at least one time on this function that I drew. Okay, happens at least one time. It looks like it might happen about here-ish, and it might happen about here-ish if I'm just kind of guessing for my secants. So it's going to happen at least one time. So the secant from your endpoints, that slope is going to occur at least one time in your interval. So love this question because this one just talks about the conditions. So we only have two conditions for MVT. We have it's continuous on the interval and it's differentiable. So which of these functions of MVT on the given interval, satisfy the conditions, and which ones do not? You give your reasons why. So we have two functions. If you can't read this, because I can tell it's not so great on the video, That's x to the 2/3. And it looks like you can read the interval there. And this is going to be x to the 4/5. Okay. So when we go through here, we gotta make sure that it's continuous and it's differentiable. So right here for this guy, these both are continuous. All right. So if I'm doing the first one, I'll do the first one in blue, so it's easier to tell. So this will be the first one. So in blue, yeah, we're continuous. But we are not necessarily going to be differentiable here. So let's go ahead and see this. So if I find the derivative, that's going to give me 2/3 x to the negative 1/3, which is going to give me, if I clean it up, cubed root of x. There's supposed to be a little cubed right here. Kind of hard to tell. So this is not differentiable at 0. So x cannot equal 0 on the derivative. And that's inside of my interval. So this guy right here is a no. Why? Because it's not differentiable. Do the next one in red here. So again, this one is continuous. There's no restrictions on the domain, so it's continuous on 0 to 1. But it looks like we're going to run into the same problem here. So let's just kind of go through this. So f prime of x is going to equal, the derivative of that is going to be 4/5 x to the negative 1/5. And that's going to equal 4/5 fifth root of x. So in this case, x cannot equal 0. But I'm going to tell you right now that this actually works. All conditions are met. If you're a little confused, let's look at this. It has to be differentiable again on the interior. This is not differentiable at 0, but 0 is an endpoint. It's not the interior. So like, yes, f of x is continuous on, I'm going to run out of room here, on 0 to 1, and differentiable on the interior 0 to 1. So yes, this one works. So just make sure that it has to be differentiable, just not at the endpoints, but in the interior. All right, let's speed some things along here and actually go through and do an MVT problem. Wrap this video up. I don't want this to take too long. So let's find the value C that satisfies the NVT. So we do need to go ahead and make sure that this is continuous. So if I'm looking at it, yeah, it's continuous on the interval. So yeah, this is f of x is continuous on the interval. Is it differentiable? If you don't know that, let's go ahead and find the derivative over here. So the derivative is going to be, this is going to be a little bit of chain rule here. So it's the same thing as x minus 1 to the 1/2. So I'm going to get 1/2 x to the negative, x minus 1 to the negative 1/2, which is 1/2 square root of x minus 1. And it looks like here that we're not differentiable at 1 or anything less than 1, but this works out because we're inside the interval. So f of x is differentiable on the interior here. So now I need to find the secant from my endpoints and set it equal to my derivative, which I just found that right there. So let's go ahead and do that. So f of 3 minus f of 1 all over 3 minus 1. What does that equal? That's going to give me, I plug in a 3 again. This is going to be into the original. Just making sure that I'm going to get everything right here. We get root 2 minus plug in a 1, 0, all over 3 minus 1, which is 2. So this is going to give me root 2 over 2. So now I need to find the c value that works. So I'm going to set my blue answer right here and my gray answer here together, find the x value, and see what graduates to a c. Could be multiple answers, could be just one. So I'm going to do, actually I'll do this in green. So I'm going to go root 2 over 2 equals 1 over 2. Oh, that was not good looking. I'll make that into an x minus 1. Okay, cross multiply here, and you're going to get, let's see here, root 2 times 2 root x minus 1 equals 2. You can go ahead and divide the 2 root 2 over, so you're going to get root x minus 1 equals 1 over root 2. Square both sides, you get x minus 1 equals 1/2. And then add the 1 over, and you're going to get x equals 3/2. All right, awesome. I only have the one x value, and this one is in between the interval like it should be, and it does graduate to a c. All right, and that is the mean value theorem and Rolle's